Solar Energy Explorations at UNI Center for Energy and Environmental Education. I'm Pat Higbee, and I invite you and your students to use our solar photovoltaic panels for a science experiment that will get them excited about STEM, solar energy, and scientific inquiry. Let's start with some information about our PV panels. We recently upgraded our system with the help of Alex Dara, the Cedar Prairie Sierra Club, and some other great friends. Our new system has 6 panels that are mounted in pairs on 3 different poles. Information about how much energy each panel generates is available online. Your students can see how much energy we are making any time of the day, any day of the week. They can also download reports, graphs, and data from the moment our system started working. Our mounting system allows us to swivel our panels in any direction, from north to east, south, west, and back to north. We can also change the vertical angle of our panels. We can place the panels in the positions that your students choose. To send us your proposal, please fill out the UNI Solar Energy Explorations at the CEEE form. You can find it on our website on the Solar Energy page. Simply give us your contact information and describe the question your students are researching. Here's an example from our first project. Mrs. Chisek's 6th grade students at North Tama School wanted to know which direction panels should be pointed to collect the most energy, east, west, or south. We did the experiment in the spring, so they asked that we set the altitude at 35 degrees for all of the panels. They also wanted to know if dirt would affect the panels, so they asked that we keep the lower panels clean. We agreed to clean the panels, but not more than once a day. On the day we put the panels in position, I created a Zoom meeting so the students could watch us work. I wore a headphone and microphone so I could hear and answer questions. We can do the same setup for your students. We loosened the nuts so we could swivel the panels and set them up with the eastern pair pointed east, the center pair pointed south, and the western pair pointed west. You might be able to see that there are trees east of our array and a building to the west. These will affect the experiment too. To make this measurement, we first used a compass on Ryan's smartphone. Later, we checked the orientation with a regular compass and found that the east and west setups were off by about 35 degrees. We then used the compass on a solar pathfinder to find south and marked these coordinates on the poles of our array. In the future, it will be much easier to put the panels in position. We also had to loosen another set of nuts to change the tilt of the panels. We used a 360-degree protractor type of level for this measurement. You can find details for the sun's position in the sky using data at the U.S. Naval Observatory. The link is on the solar page of our website. Just add the date you want, Iowa for the state, and Cedar Falls for the city name. You can get the location for every 10 minutes, but that will generate a lot of points. I'd suggest you ask for an interval of at least 60 minutes. Your students can graph this data, or you could mark the north, east, south, and west walls of your room with azimuth degrees. Tell your students that horizontal is 0 degrees and straight up is 90 degrees. Then ask them to shine a flashlight to show the location of the sun. This will help them visualize how the orientation of the panels affects the amount of energy generated by the sun. Now that the panels are in place, it's time to go to the enphase.com website to see what kind of data your students can collect. In the top right of the page, click on Enlighten Login. Use higbee@uni.edu for the email address and CEEE 2015 PV for the password. If you see a diagram with 8 boxes, you're seeing my home system. In the top left of the page, click on Systems List, then click on UNI CEEE to see the CEEE system of 6 panels. You can explore this website on your own, but I'll share just a few features. Click on the monitor image to open another set of tabs. Click on Photo to see photos of the system, and click on Environmental Benefits to see equivalents for the energy produced and carbon offset. You can generate graphs and data reports for the whole system or each individual panel. Feel free to enter different values in the drop-down menus. Each request opens in a new tab, so go back to your first tab to make new choices. Before you leave, try clicking on the green box labeled My Enlightened View in the top right-hand corner. This view gives a great visual image based on the shade of blue. Light-colored areas indicate high energy production, and dark navy areas show low production. You can change the time span to months, days, or even hours. Wouldn't it be great to compare power production to the weather? The Waterloo Airport is just 5 miles northeast of UNI. You can see hourly conditions by searching for Weather History of Waterloo, Iowa Airport. The Weather Underground lists conditions such as haze, overcast, or clear. Your students can devise a numerical system for these descriptions and then compare them to the real data on the Enlighten website. I hope your students will find this activity just as educational and exciting as Mrs. Chisek's class at North Tama. Feel free to contact me, Pat Higbee, for more details about the UNI CEEE at CEEE. Your solar energy exploration is just a click away.